Oh, just you wait till the end. All right, so adventure scaling in Node. I kind of felt like I should have renamed it Scaling in Node because now I feel like I'm setting everyone up for an adventure, which, well, we'll find out, right? So yeah, my name's Hem. I'm basically so I'm a developer. Been developing for WildD for the same amount of time as I've been developing for News UK. I've been basically helping to move the sun.co.uk onto a new platform, which I'm sure you're all avid readers of here. I can see a couple of you definitely be reading the Sun. Yeah, so I've worked before at Net-a-Porter and Sky, and I can see a couple of people here who've worked at Sky as well. It's good to see you guys again. So yeah, let's get straight into it. So this is the team I was placed with at the Sun. So you can see my manager there. I kind of feel like he needed a moustache otherwise I think he looks a bit baby-faced. We've got some actor there. We've got Tom with his winning pose. We've got Joao, I think that's how you pronounce it. We've got Sexy Fabs. Sorry? Joao. What? Joao. Joao. We got Joao there. We got who I like to call Peter Baelish because he looks just like him, but that's also another Joao. And when I first joined, the team's main objective that I was told was, all right, the business came to me, I want to add new features more quickly. And to give a bit of background as to why that was a problem is that the existing Sun website was powered by a single application. And that includes the thing that editors use to put the articles in place, the API that the mobile apps use to get the content, and the page renderer that the browsers are all relying on to serve the content as well to them. And all of those were in a single application. Yeah, it has its advantages. You can share code and all that jazz, but it ended up becoming a bit of a bottleneck for changes because a single monolithic app starts becoming a bit brittle when you're making changes here and there, and changes are a bit hard to implement everywhere. So we decided to split it up a bit, as like most people do when you see a problem like that. And the first thing we decided to split out was the page renderer. We decided to make that into a Node application powered by a component library, which was just a bunch of React components. And yeah, it was a lot easier to optimize a single application. So yeah, we thought, okay, we can develop new features more quickly now. We've got a small application, it's a bit more modular, it has its own pipeline, its own tests, which are a lot smaller. So yeah, we can now start writing features more quickly. So our second objective that was given to us was, okay, let's make the pages load faster. So yeah, we were thinking, great, we've got a Node application, let's start tackling this next objective. But there was a slight problem with the page renderer. At the time when I joined, it was just serving a single article on the entire of the website. And yeah, the higher ups, everyone else thought, yeah, that's great, we're fine. We can probably scale up to 250,000 articles overnight and we'll be fine, we'll have no issues, and we can start developing other features, making the page faster. But the rest of the team kind of knew that wasn't going to fly. We can't just go from serving a single article up to 250,000. We're going to come across some hurdles, some problems. So yeah, that's 250,000 articles of that's actually the correct amount. That's how many articles would be live on the current site, so you could find all of those. Those aren't the ones that have been legally taken down, which is actually a lot of on the Sun. This is also including the sports pages and everything else on there as well. So yeah, our obstacle, the new platform needs to handle way more traffic. It can't just handle a single article, which, to be honest, was a test article. No one was even getting to it anyway. So we slowly decided to start directing more traffic and decided to see when we would fall over. We basically started serving more articles on this new platform. The way we were thinking is that we might be able to kill two birds with one stone. We were thinking as we're increasing the amount of traffic and in getting more traffic onto the site, we should be able to increase the page performance as well, thinking that there's kind of a reverse correlation there. The better the page performance, the more load we should be able to handle. So the way we decided to do it to begin with, all right, let's just stick a cache in front of our application. So all the requests coming from Oxford, Warwick, Cambridge, all hardcore sun.co.uk readers, they'd all be coming through to hitting this cache. And but there was still a problem there. the cache is made up of multiple nodes, all kind of distributed across the UK in places like Oxford, Warwick, Cambridge, and all of those were creating requests to the page renderer. I think Akamai probably have a way of solving that, but we were too cheap to pay them to try and solve it for us. So we still got a problem. We're still getting too much traffic. So then we decided to put a cache behind the application. One of the problems we saw was our API that we were relying on was a WordPress API. And it took absolutely ages to give us our content that we relied on to serve all our pages. I'm talking seconds here, and the payloads were in the megabytes. I'm not sure why, but WordPress seems to store all of its content in its database in actual raw HTML, and it will send the entire thing back to you. So it's up to you to decide to parse that. At the time, we were just a small team. We didn't want to rewrite the entire API. We didn't want to actually do something like, as the content got written by the editors, parse that ourselves, store it somewhere a bit more readable and manageable, and then serve that in as a smaller API. We didn't get time to do stuff like that, so we put a cache in front of it. And it worked. It worked really well, actually. So we decided to put 10% of the amount of traffic we were getting through to our new application. Yeah, we're feeling confident. It's looking good. We're seeing we got 10%. Everything's stable. It hasn't fallen down yet. And we saw our response time was 459 milliseconds. That's actually less than it really was, because that's taking into account things like assets, which served a lot more quickly. But yeah, we saw the time and we were like, okay, it's not great, but we can now go back to our original business objective now that we've been able to handle more traffic, which was get the pages to load faster. Remember that correlation we kept thinking was there about reducing the amount of time it takes to load the page and being able to serve more traffic because of that. So yeah, we've basically got an app which is taking about 460 milliseconds to serve content. So yeah, now we need to actually start to figure out what all the little steps we could do to make that even smaller. First step was to profile the Node application. I mean, in the past you used to use things like Node Inspector and things like that, but I think Node now has this built in. So you can run this flag, it'll open up, it'll give you a URL which you can paste into Chrome. Once you do, you'll get that message. And yeah, basically the profiling will allow us to see what our code was doing, how long it's taking to do said stuff. And here's the result of the first profile that we had. Now I wonder if my thing's there. It is there. Okay, so this is a quick breakdown of what each of the bits of the profile was doing. The initial grey bits there was just stuff waiting around, fetching the content. We'd already made the request, we're just waiting for the content to come back. This was actually with not warm caches. Actually, yeah, we had in-memory caches which weren't warm, but yeah, this is warm in Varnish at least. But then we had a huge block of time being spent parsing. After that, we fetched more content. Yeah, we could have optimized that, but yeah, at the time, this is what it looked like. And then after that, we actually fetched we did a bit more parsing there, and then finally rendered the page. So yeah, parsing data and something else. After kind of zooming in on it, I noticed at the time that it was just a single function being called again and again and again. So looking at the function, there's some kind of promise check that was going on. It was a bit difficult to read here because our code was not readable. But essentially, the code was checking, there's this promise.resolve deep, that's not native in Node. Essentially, it was iterating over the entire object and taking a look at what was a promise and then trying to resolve it. The problem is, the payloads from our API were like a megabyte, so you've got a lot of data you're suddenly iterating over and checking if it's a promise to resolve. So that's why we kept seeing all these little function calls happening. It's just checking, is this a promise, is this a promise, is this a promise? I mean, there was a limit to how deep it went, but the problem is we just had so many key value pairs that it didn't make a difference. So basically just got rid of the dependency completely. I think I reported it as an issue and said, just kind of warn people, don't use this if you've got a lot of data. And then just fell back to promise.all in Node, and rather than having a method that goes through an entire object and checking what's a promise, I found the promises in there myself because it's our data. We know what we're doing. We know what we're doing there. So found all the promises and just returned them back up the chain and just use promise.all to resolve it all. And then reran the profiler. And this was the result. So we managed to reduce response times by 75% just by that single bit because someone had put in some shoddy code there without realizing. Started to focus on some of the larger operations in the profile after that, which was, as you can see there, the rendering of the page itself. So the renderer is React, because we've got a React component library. And we're like, okay, so what can we do to improve this? Yeah, some of us knew React, but I work for WildD, a bunch of the people working in my team work for WildD, so we just posted on our Discord channel. Hello, does anyone know a way to make server-side React rendering faster? Yeah, the manager doesn't like React. He makes that obvious everywhere. Then Nuno directs us towards this library called Rapscallion. So it's basically an optimized version of the React renderer, which works a lot better on server-side. I'm not sure, I don't think it's built for client-side at all. Essentially, just try to make a lot of the operations run in parallel. You can even fine-tune that by setting how large your batches of rendering is set to. Yeah, basically you can configure it so that you're given control of the event loop back as often as you want. But I think by doing that, you're actually decreasing performance. More on top of that, it even gives you things like hooks to basically return back cached rendered data. So it's got a whole bunch of stuff just optimized for server-side rendering. Also, it can return back in streams if that's what you're into as well. So we dropped React and dropped in Rapscallion. The README said for Rapscallion it's got a 30% improvement if you just drop it in like that. We decided to drop it in, and we saw roughly about 20% improvement actually. So we dropped by another 100 milliseconds. We could have done a lot more. We could have fine-tuned it perfectly. We decided to leave it there. We're like, okay, let's see how much more traffic we can put onto the page now. So we decided to ramp our traffic up to more like 50% of all the content on the Sun being served. So a few other notable things we kind of did was that aren't really node related. We increased the memory limit. That's because we had an in-memory cache. We did things like automated load tests, which was actually quite exciting. We made it so every pull request that got raised would create an environment in Kubernetes and create another environment to actually run load tests, give us a report and wipe it all out again so we could save some money there. Reduce traffic using edge control cache headers, so that's basically getting Akamai to cache for longer in itself, so they send less traffic our way. They cache for longer so that browsers would not have to hit origin as much, but then they would actually cache for a shorter duration on our side so that they would hit us more often. I think that's the workaround we did it. I can't remember. It was one of those. And then we did things like cache prefetching, randomizing the age of the cache as well. So rather than caches being hard-coded to 5 minutes, we did a bit of variation there so they wouldn't just expire at the same time, kind of balance the load out a bit more there. Optimized data storage, reduced timeout durations, and actually cached failed responses. So if APIs fell over, we weren't just bombarding them still. So over the past 6 months, we did manage to finally reach our objectives of managed to reduce the response times down by 20% compared to the old WordPress platform they were on. And the fact that we've got a brand new modular application, so we can do even more after that. And we managed to make it easier to add the new features initially. I mean, we've been we've been able to release way more often. We've got way less risky releases happening over the past few months. And we've been able to do a lot more ambitious things, like having a feature where you can just swipe between articles like you can on AMP pages or Facebook. I think it's instant article pages. We could do even more. There's still room for improvement. We can do things like caching rendered partials. We could render using streaming, rewrite the API. But first, we kind of wanted the main point that we kind of reached is we need to basically figure out what the benefit is of all of those features. Using things like the node profiler, you can figure out how much benefit you're going to get from these kinds of operations. And also, as you use these kinds of tools more, and as you kind of get a bit more experienced trying to improve performance and optimizing for load, you start to figure out patterns and just kind of pitfalls. We had a situation where we kept increasing in memory, so we had a kind of mechanism in place where it would cache in-flight requests, so any subsequent requests that came through would just get returned back the same content. But we didn't just put those things in place. We first made sure we knew how to measure it. We used things like benchmark.js, so we had automated tests around all of this. And we used other kind of timing tools during development itself, just to see how well things were performing. Have a way of measuring before and after, both locally and in production. Any questions? I know I kind of ran through that quite quickly, but it's getting quite late in the day as well. No?
With the server-side rendering,
Yeah.
So do you have all of your React components rendered server-side and it's still a bit of HTML?
Yes.
Okay. That's for compatibility reasons.
Yes. Initially, we didn't want to touch the client-side JavaScript too much. We thought it was going to be too big of a thing to tackle, basically trying to rewrite the entire of the Sun website. It's basically got a lot of advertisements on it. There's a lot of code littered around all over the place because of that. And it was quite hard for us to try to tackle that initially and move that all over to React and try to deliver an MVP. So we decided to return back the HTML initially rendered and then rely on the actual WordPress JavaScript that was still there. The reason we used React components to begin with, even for server-side, is initially they're just used for templates, but the idea was to eventually move over to client-side React so we could make use of those React components fully. I think now we're looking to even do things more like edge-side includes as well, using Akamai. So I think the idea is Akamai would actually cache partial rendered content and then build a page up for our users and send it back. But eventually I think we're probably going to stick with server-side rendering just for performance on shitty mobile browsers. So we're just going to end up probably doing something like edge-side includes and leveraging Akamai to build a page. And then once we get some time, we'll probably do that ourselves using something like Redis to cache our content and use Origin to build the page again. At the moment, Origin still builds a page, but yeah, we're looking to maybe leverage Akamai to do that. Depends if we can afford it, really. At the back there.
So, have you looked at the point where you're going to get diminishing returns, making the server side ever faster, and the front end is still slow? Are you measuring that yet?
Yes, we do have tools to measure the front end, and that's one of the reasons we kind of left it as where it is, because we're starting to tackle our front end performance. We got some pretty smart members in the team, which I haven't put there yet, which are tackling a lot of the front end side of things. I think I was initially brought in to actually tackle some of that front end stuff as well, but we just couldn't handle the traffic. Like our initial objective was, make the page load faster, but it just couldn't handle the traffic. So a lot of us ended up trying to improve the platform itself. But yeah, at the moment we're doing off the top of my head, we've done like a lot of the basics like gzipping assets, increasing cache headers, but then we're rewriting some of the logic as well, getting rid of some of the certain dependencies like jQuery. I think we're using an alternative called Zepto. But I think that's just a interim solution until we decide to rewrite our client side. One of the biggest blockers we have is, again, it's ads and the software used for that, all the tags managers and trying to rewrite all of that. So we're working with the ad team to basically optimize that, because at the moment, actually initially the CSS was the slowest, so we did a whole bunch of post-processing on that. And we didn't even use post-CSS. For some reason, the team didn't realize post-CSS existed, and we decided to rewrite post-CSS ourselves. But yeah, we're basically doing a bunch of post-processing on our CSS to improve that as well and reduce the size there. But yeah, we're tackling front-end performance quite a bit as well. And I know, for me personally, that's going to give the biggest win, because the experience on the Sun is pretty abysmal.
And a follow-up, what tools do you use to measure that sort of front-end performance?
What tools we use to measure it? We're using Lighthouse mainly to measure that kind of thing. I've seen reports given to us by other people from Lighthouse as well, but yeah, we've actually kind of written our own wrapper around. It's basically just made Lighthouse executable on our CI so we can have constant reports of it. So we're just seeing that all the time. We're trying to automate a lot of this stuff because we're trying to hand over a lot of development to India. And for that, we don't want to risk them putting in something that's just going to take down everything, because they already did a few times. So now we put in automated load tests, we put in automated front-end performance tests as well. I don't know what's next. If any other problems come up, we're going to tackle those as well.
And that was using Lighthouse on the CI?
Yes, that was using Lighthouse on the CI.